Our first unit is going to be on sequences. We're going to do 6 examples here. We're going to fill in the chart and work from there. Example 1, you have 5 numbers that we want to find in the sequence. That's what n is going to stand for. Back in Algebra 2, you use something called functional notation. You simply just plug the numbers 1, 2, 3, 4, and 5 in to find the first 5 terms. 2 times 1 is 2. 2 minus 1 is 1. Then you plug a 2 in. 2 times 2 is 4. 4 minus 1 is 3. Plug in a 3. 2 times 3 is 6. 6 minus 1 is 5. But again, like all math, let's look for patterns. We notice that it's going up by 2 each time. This is arithmetic. It's adding 2 each time. So without even plugging it in, I can see that my other numbers would be like this. So this is functional notation or function notation. We use in pre-calc what's called subscript notation. So we will write a sub n equals 2n minus 1. Very similar. The domain that we will use is n, the natural numbers, meaning we're starting with number 1. This is the first term, second term, third term, fourth term, fifth term. So if I want to find a sub 7, the 7th term, I simply plug in a 7 in for the n value. 2 times 7 is 14, minus 1 would give me 13. So example 1, to find a specific term, just take the formula and plug it in. Not too tough. Second example, and second and third example, just a little trickier. Example 2, find the first 3 terms of the sequence. So I want to find a sub 1, a sub 2, and a sub 3. To find the first term, I plug in a 1 for all the n's. When I do that, 1 plus 1 is 2. 2 times 1 is 2. I get 1/2. To get my second term, I plug in a 2. Work in parentheses first. 2 plus 1 is 3. 3 times 2 is 6. 1, 6. And to get the third term, I will plug in 3's for all the n's. 3 plus 1 is 4. 4 times 3 is 12. 1, 12. Pretty easy. We're going to go to example 3. In example 3, I just want one term. I want the 8th term. So to find the 8th term, I plug in an 8. 2 to the 8th power over 8 squared. 2 to the 8th power is 256. 8 squared is 64. If I divide those out, I simply get 4. So again, it's just plug in the number into the formula. So that's example 3. Let's go to example 4. This is example 4. You'll notice it has something that's a little different. It says find the first 3 terms of the sequence. It has this in the front, and I want to make sure you know what that does. So if I want to find the first 3 terms, obviously I need to substitute in a 1, then a 2, then a 3 for all the n's. So let's get this written down. I'm plugging in a 1 for all the n's, and now I'm going to plug in a 2 for all the n's. Now I'm going to plug in a 3 for all the n's. This is times between them. Let's see what this does. Negative 1, this would be to the 2nd power. When you raise negative 1 to an even power, it is always positive 1. So 1, this is 1, equals 1. 1 times 1 is 1. Now this would be 2 plus 1 is 3. Negative 1 to an odd power, such as 3, would give me negative 1. Negative 1 times 1/2, negative 1/2. Now this time, 3 plus 1 is 4. Negative 1 to the 4th power, 4 is an even number, is positive 1. Positive 1 times 1/3 is 1/3. So if you ever see this in the front of a formula, you will know that your signs will go back and forth. Positive, negative, positive. Or maybe it'll be one where it's negative, positive, negative. This is called an alternating sequence. It's example 4. Example 5 is recursive ones. Recursively defined sequence. Each succeeding term is defined by using some of the preceding terms. One very popular recursive sequence is the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13. You simply add the two previous terms to get the one that you need. For example, 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. So if I do 8 plus 13, I'm going to get 21 for my next term. And then if I wanted to do 13 to get the next term even after that, 13 plus 21 would give me 34 for the next one, and so forth. Write the formula to find the nth term of this sequence. So if I want to find an nth or any particular term, I need to add the two that are before it. So that would be 1 before it plus the 1 even before that. A sub n minus 1 plus a sub n minus 2. That's recursive. Depends on the ones in front of it. Next one. This is also recursive. It's example 5, but this is continued. I have a formula this time. It says let a sub 1 equal 5. For recursive, they must always give you a sub 1. So a sub 1 is 5. And I want to get the first 5 terms. So I want a sub 2, a sub 3, a sub 4, and a sub 5. To get the second term, I obviously plug in a 2. So if I look at the formula, it is n, which is 2. 2 times. I would like you to think of this expression right here, a sub n minus 1. When you see that, I want you to think of it as the previous term. So if I'm finding the second term, the previous term would be the 5th. So I'll plug in, would be a 5. So I'll plug in the 5. And I would get 10. So now I'm going to go to the next one. I'm finding the third term, so I plug in a 3 for n. So it's 3 times my previous, which was a 10, gives me 30. Because think about this, if I plugged in a 3, this would be 3 minus 1. It would be a sub 2, which is my previous term. So instead of plugging it in, I personally just say previous. It's the n value times the previous. So this would be 4 times 30, which is 120. And this one would be 5 times 120, which would be 0, 0, which would be 600. And that's example 5, recursive. Next thing I want to show you is factorial of a number. How do you define n factorial? Well, that's not screaming at you. Let me tell you when you see that exclamation point. N factorial means you'll multiply the number, whatever it is, by every number below it all the way down to 1. That's a fancy way of writing it out. I think you would do fine if I just said this. 8 factorial is just 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial, 5 times 4 times 3 times 2 times 1. Since this is a fraction and they have some factors that are on the top and the bottom, I could just cross those out and have 8 times 7 times 6 is 336. Although I will let you know that if I see a problem like this, I would probably just write the top as, as 8 times 7 times 6 times 5, and not continue from 5 down. I wouldn't write all those down because I could just leave it like this and cross this out from the very beginning. Just a thought. And that is our first lesson on sequences.